Sorry, I said it really weird. Meals. I said meals, like
Someone's
food.
looking forward for dinner.
I definitely am. Okay, we're gonna jump right into this. Save you some time. Since 1, 2, 3, and 4 are all the same, try and explain 1 in depth a little bit more, but then like just kind of brush over the other ones because we're using the same principles, the same steps to get to the answer. So while determining the allele arrangement, we'd always look at like the two most frequent phenotypes and see that they're pretty much opposites of each other. That is going to be the arrangement that we used for the heterozygous, because you'd see both. So for example, in question 1, agouti, wild type in mahogany is most frequent next, and then with wild type, ragged and wild type. So we line those up here as the arrangement for the heterozygous that have both of these in there. And then to B, basically you take that arrangement that you found out and you shuffle it around. So with the first one, what I did was like switch the second and third one, and then I switched the first and the second one, just roll them around. And then we look at the two least frequent phenotypes and figure out which double cross, or it basically looks like a wave from top down between the two in that arrangement, could get these are the least frequent ones right here, the phenotypes right here. We'd see which ones doing this wave out of these 3 different orders would yield these. We got that it would be the MG, A, and RG in that order. So then moving on to the C, construct a linkage map showing the map distance between the 3 gametes. We had to figure out, so then you'd move on to the next 2 sets of most frequently seen phenotypes, and depending on if they were, this is a hard part to explain, but we were talking about it a lot. We understand it pretty well. But you look at the parental types, which were the heterozygous parental arrangements from A, and you'd see out of those the second least frequent one if it's a crossover between your A and G or your A and M. And in this case, it was between G and M, the frequencies that occurred 13 and 12 times respectively, and put it into the equation, or not into the equation, but we added up all of the times that those 2 alleles had crossed over. So that would include the double cross from B. So that both happened once. So it'd be 1 plus 1 plus 13, is that was the frequency there, plus 12, which was the next frequency, divided by the total, which was 206, times 100 to get into a percentage, because MU is also a percentage. And we got 13.1 between MUs between GM and A alleles. So then you go to the next frequent one, the next most frequent phenotypes, groups that kind of coincide. 16 and 18 were the closest together. And we saw that those ones are actually, in comparison with the parental type arrangement, that was a crossover between A and RG. Did the same thing because the double crosses were a cross between those 2 alleles. We added 1 plus 1 plus 16 plus 18 divided by the total 206 times 100, 17.5 MUs. So the map would show that it's G or MG, or between MG and A, there's 13.1 MUs. Between A and RG, there's 17.5 MUs. Like a little dot, this many A, dot. That's kind of how you showed us to do it, but let's follow that. Then you take, to find the inference, we found the percentage of the time that M and G would cross over, which was, well, we want the percentage of the actual times, so then you have to divide it again by 100 to take it, to stop it from being a percentage. So it would be 0.131 times 0.175, and then divide that, or times that, because that would be or times that by the total. So it would be 4.7 times that you'd expect the crossing over to occur, or a double cross to occur. Then you plug it into that equation that we were given. Interference I equals 1 minus C, which is expected over actual, or observed over expected. And then you need to find out a percentage of that. You times that answer by 100. So 57.4% of the time, double crossing will occur. Or 57%. That's how many, not how many times it will occur, but how many times it occurred.
Like the percent chance that it will.
Yeah. Well, yeah. That's the percent chance that it occurred. That's my final answer. Okay.
So we'll just keep going on with number 2. This one's talking about the fruit flies. And so we literally just did the same exact thing as we did on number 1. It's the same exact process, those 8 steps. So for part A, we determined the gene arrangement was the wild type for the SC, S, and V, and then underneath that we had SC, the S wild type, and the V wild type. We'll be right back. For B, we determined that the gene order was, I'll just point it out here. You can kind of see that there, I guess, maybe not, but it's big S, SC wild type V over the S wild type, SC, and V wild type. C, we got that the mapping units, so the distance in between the genes, was going to be 10 map units between the S and the SC wild type, and the 33 map units in between the other two. And for D, on the interference, we got 27.3%. And so that's number 2. Like I said, it's literally the same exact process that we did for number 1, and it follows a really similar process for 3 and 4. You want me to keep going?
1 second. Just want to clarify about what that percentage means for the interference.
Oh.
Let me see. Okay, so quick clarification. The interference that we're calculating is, that percent is actually the percent of the expected double cross that actually occurred. So in question 1, then we got 57.54. of the expected crosses actually occurred. There was 2 crosses that happened, or double crosses that happened, but we were expected to see 4.7 of them to actually happen. So there was another 2.71 that didn't happen. So that was the other 50, or 46%, or 43% that didn't happen. Anyways, so next one, number 3. This one was all the same as the other one. Most expected, the most frequent phenotypes were used to find out the arrangement, the least expected, or not least, the least frequent genotypes were used to look at the order by doing the double cross loop-de-loop thing, and we found that the order was going to be C, S plus, or C, S, and G in that order, C, S, G. Then we used the next 2 pairs of frequent phenotypes to figure out the distances between C and S and G by adding up all the amount of times they happened. The least, so this one was a little different because C only had, or 3 only had 1, 2, 3, 4, 5, 6 phenotypes happening, when it's in all the other ones we've seen 8. There's 8 different possibilities that could happen. So we're missing a couple. Those missing ones were going to be the least frequent ones. So it would be a glassy-eyed fly with the other wild types, and then a coal-colored and a striped thorax would be the other kind. That you didn't see that happen ever. There was not a single one that was only glassy-eyed. So that was 0 and 0. So we used those ones as the most, as the least frequent ones, and use those as the double crosses. So 0 double crosses happened. So we just figured out the least 2 that are showing up. Frequent phenotypes were used to figure out C and S and G. And again, we looked at the ones that were changing from the parental type, that were crossing over from the parental type. And so we got C, between C and S is 5.6 MUs, and between S and G is 1.9 MUs. So then when you plug it all in to figure out the interference with that 0 in there as the observed amount, that's going to bring it to just a 1 times 100%. So 100% of the expected double crosses did not occur. So, or 0.
All right. Moving on to number 4. This one we're talking about corn, it looks like. For part A, we got the gene arrangement was going to be the AN wild type, the BR and the F over the AN, the BR wild type and the F wild type. For part B, we got that the gene order was AN wild type, F, BR over AN, F wild type, BR wild type. So you can see that there, maybe, kind of. And then for part C, we did our linkage map, and the units we came up with there was between the AN and the F was 19 map units, and between the BR and F it was 5.1 map units. And our interference number for that was 97.9% interference.
Cool. All right, finally again, our last one is different, and it's kind of cool. So for A, B, and C, kind of drew it out. So it's saying that they're on different chromosomes. So I just drew that each gamete is going to have 2 different chromosomes this one's the A one and that's the B one, so it could be big A and big B. So there was a 1-to-1-to-1 ratio to be big A, big B, big A, little b, big B, and little a, little b. That's a little a. Sorry, looks kind of weird. Looks like a big A, but I show you. Anyways, so it shows the gamut. So then when they're on the same chromosome but they don't cross over, it's a 1-to-1, but they said that the dominant A and B were on the same chromosome, the homologous chromosome, and the recessive A and B were on the other homologous chromosome. So there's 4 gametes that were produced, but these two are both big A, big B, big A, big B, and these 2 are little a, little b, little a, little b, because there's no crossing over. So then C, when there is crossing over occurring, the same ratios will happen here. Since we don't know their frequency or their map units, like in D, we just assumed it was near 50, so it happened almost the same. So with crossing over, well, actually it doesn't ask for ratios, so there are 4 possibilities. We don't know what their frequencies are because we don't know the mapping distance, map units distance between them. So same thing could happen as A, but we just don't know the frequencies. D, we said so 7.8 MUs is actually the percentage of times that like A and B cross over, or the so we put 7.8% chance of recombinance. That would be the A little b or the little a big B, since those are the other homologous dominant and homologous recessive, or homozygous dominant, homozygous recessive would be the parental types. So there's only a 7.8% chance of recombination since they're so close together, and a 92.2% chance of parental types, homozygous types. So out of 100 gametes produced, 46 would be homozygous dominant, 46 would be homozygous recessive, 4 would be heterozygous big A little b, and 3 or 4 would be little a big B. So that's what we got from those. Sorry, this one was longer, harder to explain. Have a great night.
Yeah.